This is the keyboard of the Sinclair ZX81 computer. Although the brainchild of Sir Clive Sinclair, the Zeddy, may be affectionately remembered, the keyboard is universally reviled as an input device. Sir Clive was well known for ruthlessly cutting costs at the expense of convenience, and at some points even usefulness. It is easier to program on a modern emulator than it is to use the actual computer. But I want to be able to program directly on my original hardware, and I decided I needed a better keyboard. There are many examples of others building tactile keyboards, and I wanted to take a stab at building my own custom device. The first need, of course, was to understand the keyboard interface. Thankfully, I kept my crumbling keyboard from a previous replacement video. Looking at the circuit from the backside, you can see a very simple design. The 40 keys on the Mylar keyboard are cross-connected by a 5x8 matrix. Whenever any key is pressed, one of the 5 columns is connected to one of the 8 rows. The mapping is simple once you understand the connections on the back. Each of the 10 keys across any row is connected to one of the 5 columns, with 2 keys being connected to each column. Looking at the wiring, the first and the 10th key, second and 9th, and so on, all belong to the same column. The 10 keys of each row on the physical keyboard, however, are split into 2 logical rows. And that is how 4 physical rows become 8 logical rows. Understanding this, now we need to settle on the key switches to use. Much like Sir Clive, I decided to go cheap. Instead of using standard MX key switches, I went with simple tactile buttons. Next, I designed my keyboard circuit in KiCad using the bottom-up circuit wiring layout as conveniently exposed on the keyboard replaced from my ZX81. As an aside, one feature of standard 4-pin momentary switches is that the 2 pins on the left and 2 pins on the right are always connected. It is when the button is pressed that the left and right pins become connected. So why is this important? This feature allows me to use the switches themselves as a second layer to my single layer board. The 2 pins on each side act as a bridge over any routing that I may run through the gaps. This is something I could not do with a 2-pin switch. I attempted to duplicate the key pattern as best as possible from the original keyboard. Next, onto my Genmitsu router to mill my PCB. I do have to say, at this point I am very pleased with myself. The PCB milled beautifully on my very first try. Time to start popping in key switches and prepare for soldering. And this is where my mistake becomes very obvious to me. I correctly laid out the wiring from a bottom-up perspective. However, I laid out the key assignments from a top-down perspective. And now I have a mirror image alignment. My first decision was to continue on, as the circuit is correct and the keyboard should functionally work. However, later on I will question that decision. So I persevere and solder in 160 pins. Keyboard is complete, and the tactile feel is amazing compared to the hard Mylar keys. So time to connect this to my TS1000 for testing. Somehow my video, which was never perfect, seems to be degrading. But that won't affect my keyboard testing right now. And I have a replacement ULA and a conversion to composite output for a future project. Even with my misalignment problems, I have created a keyboard that functionally works. However, after some quick typing, I have come to realize how much muscle memory affects even hunt and peck typing. I am continually thrown by keys that should be to the lower right and are instead to the lower left. And I quickly realize that I will in fact relay out my keyboard and purchase 40 new key switches and redo this project. Back into KiCad to adjust the layout and routing. And back to the Genmitsu for 3 more hours of milling. I plan on designing a full case, but right now I just need a template so that I have something to apply the ZX81 specific keyboard labels to. I designed this in Fusion 360, remembering to add a cutout for the ribbon connector. One hour later, from the 3D printer, we have a keyboard template. I purchased these ribbon cables from DigiKey, which work nicely with the existing connectors. I made a simple scanned image from my original ZX81 keyboard membrane and used a photo editor to brighten and apply a little scaling to the key labels. After cutting out and applying with some glue, voila, a homemade ZX81 keyboard. So after all is said and done, I have reinvented the chiclet keyboard. Is it better than the membrane keyboard? Absolutely. Will I be typing my memoirs on this keyboard? Absolutely not. So I will charitably give myself a grade of B- for this project. An IBM Selectric this is not. And I still have to hunt for basic keywords on the keyboard. Thank you for watching, and I hope you've enjoyed this video.